All right, this is day 9 of doing math problems until a Hololive member notices me. So, we have 4 equations, and we are pretty much asked to find x to the 4 plus y to the 4 plus z to the 4. We know that the first equation is equal to 1, the second equation is equal to 2, and the third equation is equal to 3. But, how do we find the last equation? Pretty much we're going to use symmetric polynomials and expressions to be able to find the fourth value. As we see, there's a pattern. The first equation is 1, the second is 2, the third is 3, so we would obviously assume it is 4, but that is not the case here. So we have a lot of different ways to approach specifically this entire problem. We could either use Newton sums or pretty much do everything from scratch and do it from pretty much the first equation working up to a second, third, and fourth, which is what we're going to do. So let's go ahead and look at the first equation because we know we have x plus y plus z is equal to 1. And if we have to square both sides, we will have x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz, and that is equal to 1. And we know that x squared plus y squared is equal to 2, so we could simply have 2 plus 2xy plus 2xz plus 2yz. And that is all equal to 1. And here we could simply subtract 2 from both sides, which will give us 2 times xy plus xz plus zy. And that is equal to -1. So pretty much dividing everything by 2, we find that pretty much the pairs of all the values x, y, and z must be equal to -1/2. So xy plus xz plus zy is equal to -1/2. So we will keep that, which will become handy for us. So we have xy plus xz plus yz is equal to -1/2. So pretty much now what we're going to do is look at the third equation, and to that we're going to cube the first equation. So we will have x plus y, I should make that smaller, x plus y plus z cubed is equal to 1. And expanding the left-hand side, we'll have x cubed plus y cubed plus z cubed. And pretty much here what we'll have is pretty much 3 times, we're going to simply just factor out a 3 from here. And we're going to get x squared y plus x squared z plus y squared z plus y squared x plus, let's see, z squared x plus z squared y. And we will pretty much also have the triple product of all the roots, which will be 6xyz, and that is all equal to 1. So we pretty much have a bit of an issue here, right? We don't know what this is, neither xyz. So how would we go on about finding it? Well, we could use the equation we found to our advantage, because we notice that we have xy, xz, yz, yx, zx, zy, and pretty much that resembles kind of our found equation. So what we're going to do is simply focus on just the parentheses first. So what we're going to do is going to go ahead and factor a x from every term. So we have xy plus xz And then after that, we will have plus y times yz plus yx. And then we will have plus z times zx plus zy. And what we're going to do is simply add whatever is missing to complete this form. So we will have x times xy plus xz plus yz and plus y times yz plus yx plus xz and plus z times xz plus zy plus yx. And that means that we're going to simply subtract what we multiplied in here, so which is going to be xyz, so it's going to be minus 3xyz. And we could finally factor out whatever x plus y plus z is multiplied by, which will give us x plus y plus z times xy plus xz plus yz. And that is minus or subtracted by xyz. So pretty much we already know what xyz is and pretty much the pairs of x, y, and z. So we could replace this with 1 times negative 1 half, which will just be negative 1 half. Negative 1 half. So pretty much we could replace everything inside the parentheses with simply just this expression. So we're going to do that. And we will have minus 1 half minus 3xyz. And it is going to be plus 6xyz equals to 1. And we know that x cubed plus y cubed plus z cubed is 3, so we could simply also just switch that with 3. So here what we're going to do is go ahead and subtract 3 from both sides, so we will have 3 over 2, or negative 3 over 2, minus 9xyz plus 6xyz minus, or is equal to negative 2. And here I'm also going to combine the xyz's, which will give me negative 3xyz. And I also added 3 over 2 to both sides, so negative 2 plus 3 over 2, which is going to be negative 1 over 2. So xyz is going to be yz is equal to 1 over 6, because we're divided by negative 3, and negatives will cancel out, giving us a positive. So we have x plus, or xyz, is equal to 1 over 6. So we're going to go ahead and move on to pretty much our fourth equation, which we will go ahead and find its value of. So pretty much we're going to go ahead and look at our first equation again, and we're going to raise it to the fourth power, which, as you could tell, this is a pretty much like the long way to get to the solution. After I do all that, I'm going to pretty much show how to get the answer very quickly with Newton's sums. So pretty much what we're going to go ahead and do now is raise x plus y plus z to the fourth power, and that is going to still be equal to 1. And here, the left side will become x to the 4 plus y to the 4 plus z to the 4 plus 4 times x cubed y plus x cubed z plus y z cubed plus x z cubed plus y cubed x plus y cubed z. And pretty much we notice that we have a lot of cubes in this expression. And we will have plus 6 times x, y, pretty much everything's going to be squared, and plus y squared z squared plus z, or x squared z squared. And then pretty much what we will finally have is plus 12 times x squared yz plus x yz squared plus x y z squared is equal to 1. So we see we have quite the expression. So I'm going to go ahead and pretty much just underline everything with specific colors so we know what we're working with. Actually, I'm gonna just use red for that one. All right. So pretty much we're gonna start off with the 4 times everything else. So we have x cubed times y x, or actually the x squared might be better. I'll just stick with the x cubed. So we have y plus z plus z cubed times y plus x, and then plus y cubed times x plus z. And we have, what we're going to do is pretty much add whatever we could to factor everything out. So it's going to be x cubed times x plus y plus z, and then plus z cubed times x plus y plus z, and plus y cubed times x plus y plus z. And we're pretty much going to be subtracting x to the 4 minus y to the 4 minus z to the 4. And we know that pretty much the x plus y plus z is 1. So we could just have x cubed plus z cubed plus y cubed. And pretty much we know that that is 3. So we'll have 3 minus x to the 4 plus y to the 4 minus, or plus z to the 4. So pretty much we already managed to simplify our expression a bit. So we're going to have it all multiplied by 4, which is going to be 12 minus 4x4 minus 4y4 minus 4z4. And now we're going to go ahead and look at the pink one. And we know that it's simply just our first equation that we found, all squared. So what we're going to have to do is square x plus y, or xy plus xz plus yz. So we're going to have, we're just going to start off by squaring this expression. So we're going to go ahead and look at x squared y squared plus x squared z squared plus y squared z squared plus 2 times, okay, so that will be x squared yz, okay, and then plus xy squared z plus xy z squared. That is equal to 1 over 4. And here, what we're going to simply do is we need to understand that if we pretty much factor in x from all this, we're going to have x times x, y, z, and then plus y times x, y, z, and then z times x, y, z. And we know that x, y, z is 1/6, so we can replace all that with 1/6. So 1/6 times x plus y plus z, which will just simply be 1. So pretty much this will just become 2 over 1/6, which in turn will just be 1/3. And we have to subtract 1/3 from both sides. So this will be equal to 1/4 minus 1/3. And this will just be 3 minus 4, which will be negative 1/12. Negative 1/12. So pretty much we have that this is negative 1 over 12. And finally, the red part, we will have x times x, y, z plus y times x, y, z plus z times x, y, z. And pretty much we already found that out, which we know that this is going to be 1/6, so it's pretty much going to be 1 over 6. And that is just going to be 1 over 6. So now we could go ahead and finally find x to the 4 plus y to the 4 plus z to the 4. So we're just going to have to add everything. So we have negative 3 times x4 plus y4 plus z4. And then we have plus 12. And then minus 1 over 6 times 1/12, which is going to be negative 1/2. And then plus 12 times 1 over 6, which will just be plus 2. And that is all equal to 1. So we're pretty much going to go ahead and subtract, pretty much combine everything. So we'll have 14 minus 1/2, which will just be 28, 27 over 2. And we're going to subtract that as well. So that will be equal to 1 minus 27 over 2. And this will just be negative 25 over 2. So pretty much we have that this is negative 25 over 2, and divided by negative 3 to both sides will pretty much give us 25 over 6, meaning that x to the 4 plus y to the 4 plus z to the 4 is equal to, you guessed it, 25 over 6. Woohoo! That was quite the pain. Ay, ay, ay. That was fun. So pretty much we found out that this right here is simply equal to 25 over 6. And we just erase this. 25 over 6. So pretty much we did all that long work when we could have just used Newton's sums. And pretty much what Newton's sums pretty much relates to is it pretty much relates all of the powers, right? So to use Newton's sums, we have pretty much S sub n, and that is equal to x to the n plus y to the n plus z to the n. And pretty much like these are elementary symmetric sums, and pretty much the recurrence formula that Newton's sums is pretty much just Sn times x, or is equal to x, and the recurrence formula pretty much is Sn is equal to x plus y plus z times Sn minus 1, and then minus xy plus xz plus yz times n Sn minus 2, and then minus, actually plus, and then pretty much just x, y, z, Sn minus 3. And pretty much like, this is just for specifically this form that we have. And if we pretty much just go ahead and find S1, S2, and S3, we could just say that S1 is equal to 1, S2 equals 2, S3 equals 3. Pretty much these values. And pretty much if we want to find x to the 4 plus y to the 4 plus n to the 4, what we can do pretty much is plug in S4, and that will be x plus y plus z, which is just 1 in our example. So it would just simply be Sn, or 4 minus 1, which is 3. We know that that is 3, so that will be 3 minus, and then since we found that earlier, we're going to have negative 1 over 2 times Sn minus 2, which is going to be S2, which is pretty much multiplied by 2, which is just going to be positive 2 or positive 1. And then after that, plus xyz, which will be plus 1 over 6 times S4 minus 3, which is going to be S1, which will give that. And pretty much you have to combine everything, which will be 4 plus 1 over 6, which then will be 24 plus 1 over 6, and that pretty much equals 25 over 6. So pretty much we found the sum using Newton's sums pretty much very relatively quickly. And of course, we would still have to go through the process and trouble of finding xy plus xz plus yz and xyz. So that pretty much sums up all of this in a nutshell compared to the long way we took by finding and manipulating a lot of expressions. But overall, we managed to also explain what Newton's sums does. So pretty much that's it, and hopefully you guys liked it and watched me suffer even more. So like, yeah, fun. Woohoo. Jeez. When will Crony notice me? Like, come on. I'm waiting and I'm putting in the effort. All right, but that's pretty much where I say bye-bye and thank you for watching.